We have seen in previous chapters that load and store word had three different ways of specifying the memory address. So we said that, for example, you can do something like that. So you had load word, a register, and a label. So this was one way. And then somewhere you had this, the array label. So you just put the label, and that label is pointing to that address that you want to load from. The second option was that you are giving a register instead of a label. So you are putting here, let's say S0, and then you have S1, and then S1 is actually holding your address. So maybe later or somewhere before you had this load address S1 array. So basically, first you load this to that, and then this S1 is being used to do the load word. So basically, you are using a register instead of a label. So that was the second case that we see. The third case is very similar to the second case, except that you can have a constant. So we see something like that in the previous slide, that you can put here, for example, -4. So something like load word S0, -4, S1. And this constant is being used to basically add it to this address. And then your final address is the sum of these two, and then that would be where we're gonna read from the memory. If this constant is bigger, you can use the same load upper immediate. We've seen that in previous slides, how to construct that 32-bit address. So then you can use with this as an offset. So that is basically our three options. Now let's look at how we can use a label. So what actually happens when you use a label? Because as we talked before, if you have that label, this label does not show in the machine code. So this label actually doesn't exist. So this, for example, if it's 100010000, so that's basically going to be replaced here. But we also saw that in our load word, we have only 16-bit. So how you can replace this? Because this is going to be 32-bit. And load word had only basically 16-bit. It's an I format. So it falls into the same category of what we saw here. So then that means that we cannot really directly use this. We cannot save that address, that 32-bit address, into a 16-bit position that we have. So what we can do, we have to construct that address. So let's look at the example. Here we have address of X. So let's say this is your data section, and this is X. This address of X is given here. So that is 10010008. So that's the address of X. We have that. We are on Mars or assembly, you are doing this command. So you are doing a load word JSON23, and then you are putting that X there. So very typical, very straightforward, nothing fancy. But as I said, again, this is 32-bit address. We cannot basically store this whole address directly into a 16-bit location that we have for I format instructions. So what happens? When we assemble, this is going to be converted to this. So basically, first, we are doing a load upper immediate. So let's say the register 1, that is kind of reserved for the processor. We are doing a load upper immediate register 1, and then the upper part of this address, basically. So we get that 1001. So at this point, it's going to be 10010000. So that's basically the only construct in this upper part. And then we are doing an OR with the lower part. So this is number 8, or we could put also in hex that lower part. So we are doing OR with itself. So here we are doing basically 0, 0, 0, 0, 0, 0, 0, 8. And if you do an OR, we said that the zeros gonna get themselves. So these zeros are gonna get themselves same. So anything OR with the basically X or anything is going to be X. So these are zeros. We're gonna just get this part 0, 0, 0, 8. And these are zeros, so we're going to get that port. So 1, 0, 0, 1. So that is going to be the register 1. And now you can see that we basically built this address into this register 1. And then the next step is that instead of using this format, we are going to use a regular format that has the register. So we are doing a load word. We are not giving it any offset. The offset is 0 here. And we are using register 1 as our basically register that has the address. So kind of straightforward. We can do this better. So there is one way that we can make this more efficient, and that is just to get the, so at this point, register 1. So let's remember that X was, so our original address that we wanted was 1001, 0008. So that was in the previous slide, the original address that we wanted to load from. So you can do this in 2 instructions. So first, you just load that upper part into register 1. So register 1 is going to be 1001, 0000. And then when you are doing your load word, remember that in the other case, we had the OR here, and then we had here 0 as an offset. Now, after doing this upper part, so basically this one is getting taken care of in the register 1. So we have that. And this is actually 16 bits. So we have here for the I, we have 16 bits. So we can put directly this one as the offset. So then let's say here we have 0008. So that's the offset 16 bit. And this is going to be added to the register 1. And we know that this is going to be 0 and this is 16 bit. So it's only going to be added to this part. So it's not going to change this. So it's going to be plus here now, 0008. So the address that we're going to be loading from is going to be this 2 added, which is going to be 1001, 0008. And that's the original address that we had here as X. So that's a bit more efficient. Basically, we have saving one step in doing this. And basically, that's how we can have a label and do a load word basically with a label. So here is a list of the instructions that are using I format. There are still some more. We're going to look at them later, but this is basically so far what we talked about. You see all these load words, load restore byte and load byte. So all that are there, plus some add instruction and some of the logical instruction like OR or XOR. So this is a list that you can, basically if you are doing any translation, you can refer to this and make your assembly and disassembly.